there is a Black Friday thing on Udemy with some really cool training on machine learning that you can check out. And probably you've seen already that we can definitely use machine learning to make money for others, but how about making money for ourselves? Maybe retire early. So next speaker is going to show us how. Oh, you're giving candy. I was thinking maybe you're giving money to everybody. So.
No.
Stage is yours.
Yeah, thank you. Okay, so hello. For all of you who are upset you didn't get a candy, you still have the chance if you ask relevant questions, of course. First, I want to thank you for attending my session. Of course, I want to thank Silvio for introducing the machine learning world, so to say, and paving the way for more interesting stuff. My name is Andrei Bâcu. I work as a senior data developer at well, now Powered Betfair. We recently had a merger. And I'm going to discuss today on how to predict football results, and more specifically, English Premier League matches. So first, I'm curious if you could just raise your hand if you watch English Premier League or... Okay, cool. Okay, so if I will say during my presentation that, I don't know, Sunderland will win the English Premier League this year, maybe you'll start booing me or just throw stuff at me or something like that, okay? Okay, so it goes. What do I mean by this concept of game DNA? If you think about it, you have the home team and the away team. And their gameplay is unique throughout every season, every match that they play. The player performances are also changing. One player may just have a really bad day, right? Or he can be a genius out there on the field. So we can look at this as an artificial game DNA in which all those tiny events in a football game, such as passes, goals, fouls, tackles, can be seen as individual genes, right, specific to each team. Some teams prefer to construct towards the goal, right, with a lot of short passes and dribbling. Others prefer to use long passes directly to the attackers, right, so they could score maybe easier. And I want to propose analytic project on English Premier League data that I've collected, and I want to split it initially between the goalkeeper, defender, midfielder, and attacker. These are the four roles that we have in a team, right? And this approach will be a bottom-up one, where I start from individual player ratings and features, and I want to go and aggregate these features over at team level and then game level, right? Okay, so let's see how it goes. There are out there a lot of websites that provide the so-called expert ratings for players and teams, and not only for the English Premier League, right? We have for our internal championship, and for other countries, of course. You can see here, there we go. You can see here the player statistics. Here is the summary, but you have also more details. The website is called whoscore.com if you want to access it. It's freely available data to collect for there. Of course, you have team statistics. You see, this is taken yesterday, as of yesterday, so you see that Chelsea has the highest rating. There are also some interesting features, such as possession or success of passes, the number of aerials won, and many more others. Okay. One of the main sources that was used in my project, and this is not really free data. Actually, me and my colleagues, including George, who had a presentation today, were present at the data hackathon in London. We were given this last year's data to use it to predict the results of a few English Premier League matches, and they provide like over 70 event types correlated with hundreds of qualifiers. And for example, you see here for event type 1, which is a pass event, all sorts of passes like long balls, if there is a corner, an attacking pass, and so on and so forth. Well, this sounds really great, but the not so great thing is that data kind of looks like this. Really ugly XML. You will really struggle in parsing it. You can see here that for each event are associated more than one qualifiers. The values are really nasty. Some of them are list, and so on and so forth. It was a bit of a struggle for obtaining a clean data set to use in our prediction. However, after doing the data collection, the data cleaning phase, I have used an iterative pruning strategy in which I took the list of features that I had. There were like 300 or something like that. There were a lot, and you can imagine not all of them are useful. So as I said, I want to split this data set into the 4 roles for the players, and I ended up with this, well, subset of optimal features to use for the attackers data set. For the defenders, the same, and midfielders and goalkeepers. And you can easily notice a few of them can be successfully used globally, so to say, so for all player roles, such as assists or successful passes or features regarding goals. Okay, but how can we use these features to build our image on the team? And then how can we use these metrics to drive and to predict who is the team that will win the game, or whether it's a draw, of course, and who is the team who will lose the game? And I don't necessarily refer here to the actual score. That it's a bit harder to predict, but this is really important to know who wins the game. Okay, in order to do this, we had to remove all features with direct influence on the match outcome, such as features related to goals scored or assists, and of course the goalkeeper clean sheets. And this was done in order not to obtain some really trivial rules that will be used for predicting the match outcome, right? This is what I ended up with, and this is just the top 25 highest gain ratio attributes at the team level now. You can see some of the most interesting ones, maybe successful short passes or crosses corners. The red card is also important because when a player takes a red card, it really disrupts the football match, right? His team remains in 10, has a big disadvantage, and of course many other features. If we're going to take the team ratings from the website that I showed you at first, so here you have some interesting team ratings, and these are done by experts, right? So I kind of trust them, if you know what I mean. Okay. This was the best subset of team ratings, the features for team ratings that I got after I did a analysis on the available data. So we have the team average rating, the difference of ratings for the 4 types of players, and minimum and maximum ratings for attackers, because attackers are usually the ones who score goals, right? And the goal features are really important for the match outcome. Okay, let's see how we did. I tried a couple of different algorithms, of course, after looking in some research articles and papers. I ended up using this short list. The best one, these are the best ones, but this was quite easy to implement in R. By the way, I was using R, so for those of you who are familiar with this, I can provide you also with a sample of the code, and you can try this stuff over. And now that Silvio showed you in Azure Machine Learning that you can use R scripts, you can upload your code to the Azure ML Studio, do some demos over there also, and gain advantage on scalability, that stuff. This algorithm implements actually support vector machines. This is a really good regression library that you can use. It's quite performant. Of course, there are other algorithms, sorry, such as functional trees, another support vector machines library, and of course the omnipresent naive Bayes. Okay, you can see the percentage of correctly classified predictions is quite good, so 90%, and with the area under the curve of 0.94 and 0.97. The F measure is also looking really good for these two. So the results are quite promising. Okay, but this is just a match outcome. What can we do next? We can use aggregated team ratings. Before we used only a subset of these 8 attributes. If we extend this to 27 attributes, you can see that the percentage of correctly classified instances doesn't vary too much, actually. And moreover, if we're really curious, and this is what we really want to achieve, is predicting the next match outcome, right? We have the current season, but we want to know who will win, and the next matches, and of course, who will win English Premier League 2016. I'm curious, who do you think will win? I haven't figured it out yet. Okay. If we use aggregated ratings for past matches, and you can see here the window size, and sorry, this I forgot to explain a bit. So the window size actually represents the number of seasons worth of data that I'm using in my analysis, and here is also. So this is last year's season only. This year, this is 2014 and 2015, and I'm going back 10 years. You can see that the performance really drops quite significantly to about 61%. And this is quite explainable because a team and its players evolve usually to a better game from one season to another. And because there are a lot of discrepancies between the gameplay of teams 10 years ago than last year's season, the support vector machine regressor doesn't really do a great job. So in the final analysis and predictions, I used only last year's season data, and of course the data that I have for this season, right? Okay, since I represent, I work for Paddy Power Betfair, of course that I want to use some betting odds, right? So there are a lot of websites such as oddschecker.com that offer betting odds for the Premier League winner and for other championships. And you can see here some really good odds which are highlighted. See Bet365, Paddy Power, Betfair of course, and many more. So if I want to include these betting odds in my analysis, I did that, and actually it did not improve my the algorithm performance. In some cases, these metrics drop down a bit in the accuracy, but the curious thing was, if I used only the betting odds for trying to predict the match outcome, I got for 15 matches out of about 23 results with 100% accuracy. So I'm inclined to believe that the betting odds can give you a really great advantage if you know how to use them. I will continue to invest a bit of more time in analyzing such interesting features, and maybe in another session I can show you also a demo. Now I don't really have the time to do that, but maybe in a future meetup. And of course, we can have other predictions. We can try to predict the exact score, the top goal scorer, the number of cards, fouls, shots on target, and corners, and we can place our bets on this, of course. As Cyprian and Sylvie said, maybe it's a good plan for retirement. I don't know yet. I'll tell you. Yes, please. So the question is whether it would make sense to generate betting odds from.
Based on the winner prediction. Rather than how they get to probabilities of winning.
Yes, indeed.
So can you use those to generate betting odds?
Yes, but you would be using still a prediction, which you don't know if it's good or not. And the betting odds, these are calculated by experts using other ratings. I don't know, they go out to football games, they observe the player performance throughout the season and all that. I could try to do that, but I don't think I'll get. Sorry? Yeah. Yeah, I understand what you're saying, but no, I didn't try to generate betting odds. I guess there are methods to do that by using machine learning or other methods. So, candy for you. These are more Christmassy, winterish, so if you like these better. Still have 4 left, so.
Shouldn't we try to predict tennis matches? Because there are quite a few nice variables. Because here you have to have 11 players or actually 20 something. And also some of them can have accidents and require and stuff like that. We can do a lot more much better tennis players. We can have a productive one for that.
Okay, so what's the actual question?
So can you do that for tennis and get a now?
Do you want to predict the outcome of tennis matches?
Yes. It should be easier.
Yeah, I guess you can apply. Yeah, I guess you can apply the same methods if you have data available, of course. I don't know, I'm not aware. I know there is data available for NFL, like American football, stuff like that. For tennis, I'm not aware, but you can try. There's a can for you. Thank you. Okay. Other questions? Yeah. Okay. You're first. Okay, go. Go ahead.
So you mentioned both regression algorithm and classification. So we're doing regression or classification.
So I mentioned classification.
On the previous slide, you mentioned the support vector regression algorithm, SMO.
Yes.
There is for regression, and then you mentioned correctly classify. So are you using regression or classification?
You can transform actually the classes into numbers back and forth. You can. You can. I use the regressor for this one, and for example, the away team win can be a -1, the draw can be a 0, and the home team win can be a 1. Then you can use regression, for example, right? But you can use a classifier. It doesn't matter. It matters how you structure your data for the end result, for the classes. Okay. You have candy. Okay, go ahead. Yeah.
Okay, so if you get to, let's say, 99% accuracy, how big the volume?
99% accuracy. Oh, you're optimistic.
I'm not sure what's your goal.
Sorry.
What's your goal?
What's my goal?
How will this impact?
My
For example, if you have 100% accuracy, then what's all of that already?
The thing is, you may have 100% accuracy for, I don't know, the next 3 matches. But you can't get 100% accuracy for all matches. Because, for example, take for instance, there will be heavy rain on the field, right? A player might be injured. A red card can be awarded just like that, and that disrupts the whole game. You may have other similar games, right? But every match is unique, and this is what I meant with the game DNA part. Every match is unique. You may think you can predict the outcome and other measurements, but my opinion is that you can't really be 100% sure, not even 80 or 90% sure, even if the metrics say that, right? Sorry? The betting industry. This already impacts the betting industry. I think the ones that compute betting odds already use such methods because this data is freely available online, and of course you can buy it as a product from Octasports or other providers. So I'm not the first who would try to do this kind of analysis, right? Yes, please.
How did you decide which attributes to use? You mentioned on the slide that you use data attributes. How do you measure the efficiency of each?
So the question is, how did I decide which attributes to use? Okay, so go back to these features.
That was a different slide.
Team attributes, for example, this one. So as I said, I used an iterative pruning strategy in which I took the whole data set of features, which was like 300, 400, and gradually pruned them or eliminated them based on their relevance, the correlation coefficients with the outcome and the other features, and many more aspects such as this. And this is just the best subset that I consider, but I can try and experiment. What if I add 2 or 4 more features? See how that goes, how that influences the match outcome. You can do all sorts of experiments. This is just the analysis that I managed to do so far. Part of data was obtained online, so this from whoscore.com, and this data was provided as part of that data hackathon that we participated in from Octasports.com. This is not free. Yeah. So, no question. Yeah. As Candy goes. Thank you. Okay. We have 2 more minutes, so if you have any. Yes, please. About Leicester.
And what do you think that went wrong? Team attributes were wrong, calculated or player.
Okay, so the question.
What was the surprise?
Okay, so the question was around Leicester team for performance for last year. Yeah. I didn't quite analyze last year's data. I focused on this year's data, but I can do that and get back to you with some predictions, some results maybe. You can analyze a lot of KPIs actually. So we have 300-400 measures that you can analyze separately, and you can see what influenced the team going, the team performance going down or up, or stuff like that. Okay, yeah, please.
So assuming you have live data from Octasports, can you analyze it? As
So assuming I have
live data from Octasports,
yes.
can you analyze analyze the game as it evolves?
Yes, if you Yes, of course. If you have a real-time stream, I don't know, if you use Kafka to stream data into Azure ML, for example, you can do really quick analysis over there. Yeah, you can take advantage of the cloud scalability. So yeah, it's an idea. I plan to do that somewhere maybe in the future, but yes, it's a good idea. It's doable, definitely. Done? Okay.
Last question, maybe?
Yeah, I have last questions. Just want to close up the slides. Okay, I just wanted to close up with this interesting quote. So I'm gonna read it out loud. So every match is a contradiction, being at once both highly predictable and highly unpredictable. The simplicity of the rules and the familiarity of the tactical moves makes every moment of play immediately understandable to the watching eyes. But despite this, nobody can ever be sure what will happen next. Okay. Thank you for listening.
Thank you. So we're gonna have another short break. Go grab some coffee. It's already late in the afternoon, so we need some more energy.